Now we can use SPSS to do the same thing. Using SPSS, find the point estimate for the true mean pill weight and perform a hypothesis test of whether the process of producing pills of a different weight than the intended 57.6. Okay, so now let's talk about that. Okay, what is our hypothesis here? Right? We need to discuss what our hypothesis is going to be here. So let me bring this up here. I'm not going to need this right now, I don't think. Okay, so let's see. The manufacturer claims that the mean weight of the pills that he's producing is equal to 57.6. Okay? Now, if that's true, now we want to see if that is true or that's false. So, for starters, we always start by stating that as if there's no difference between what we sample and what the manufacturer claims. So in other words, our null hypothesis is going to be equal to mu is equal to 57.6. Okay? Our alternative hypothesis, what we're trying to prove, is going to be the opposite of that. In other words, mu does not equal 57.6. Okay, that hypothesis is two-sided. The reason why I say it's two-sided is because the way this hypothesis is phrased, in order for me to either accept my null hypothesis as is or reject my null hypothesis and accept the alternative that the real mean is different than 57.6, it's two-sided because I can reject the null hypothesis if I determine that the true mean is likely to be less than 57.6 or more than 57.6. Either way, I could reject the null hypothesis. Now, if we were looking at single-sided hypothesis, let's say, for instance, that I wanted to argue that that guy's pills are shorting us, that this expensive supplement. So I want to prove not that they're more, I don't care that they're more, but I want to prove that they're less. Mu is less than 57.6, equal to or less than 57.6. That would be a one-sided alternative hypothesis. This is a two-sided alternative hypothesis. A two-sided alternative hypothesis is more rigorous than a one-sided alternative hypothesis. Because when you look at the normal distribution, what you're saying is, he says the mean is 57.6, but we think that the mean is different enough that it would only occur less than 5% of the time. So, okay, so if we do a two-sided alternative hypothesis, in order to have a two-sided alternative hypothesis, we have to have a number that we think the real mean is that's so different that it would only occur on the high end 2.5% of the time, and at the low end 2.5% of the time. Now, if I were to do a one-sided hypothesis, we're only concerned that it's not less that it's less than this amount for us to reject the null hypothesis. Well, then I can put all 5% down here, which means my z-score that I would need, the number of standard deviations or standard errors away from the mean that I would have to be for a two-sided hypothesis, is going to be, for a large sample, it's going to be 1.96, right? Okay, but for a one-sided hypothesis, it might only be, say, 1.7. So it doesn't have to be as different for me to reject the null hypothesis, accept the alternative for a one-sided hypothesis than for a two-sided hypothesis. Don't worry about this too much, because most of the time you're going to be working with two-sided hypotheses like this. Okay, so let's give it a try. Okay, so now in this case, my 95% confidence interval suggests that I already know what the answer is, that we're going to be able to reject our null hypothesis. Let's put this data into SPSS. I'm going to try not to fight SPSS on this again and concede and let it do it its way so that we don't spend too much time here fighting with it. Okay, let me open this again. I'll open a new data file. Okay. Oh, I think I know what I did wrong there. Did I say new or open before? Open data file. Yeah, I said open. Otherwise, it wouldn't have come up this way. Okay, so I'm going to paste in here. Okay, I'm not going to bother at this point to change. Oops, I didn't copy that correctly. Try that again. Oh, I got the wrong table. Let's see. What happened to my... Did I close that file? Don't tell me I closed that file. I guess I closed that file. Oh well. Okay, I guess I'm typing again. Let me get a new data sheet. All right, let me pull this back up here. Let me just take a look at questions in the meantime. The null hypothesis is that the weight is 57.6. Yep. And the alternative hypothesis is that it's different than 57.6. Okay. Did I answer that question? I don't know how that question was sitting there so long. Let me put this on this side. I'll be able to get these here at the same time. There's other stuff on my desktop you can't see. That's why I'm having so much trouble moving stuff around here. 57.3, 57.4, 57.2, 57.5, 57.4, 57.3, 57.0, and 57.1. Okay, and there's no data in that one. So let's see what my mean and my descriptive statistics looks like. Descriptive statistics explore. I'm not going to change the variable name here. We've seen that already. I'm going to say okay. Okay, and this time, I didn't tell it to plot the, maybe it did plot the histograms. Usually it remembers from the last time that you did something, that didn't. Analyze, descriptive statistics, explore. Into plots, I'm going to go in there and tell it to do a histogram as well. Okay, so I can just tell from the box plot that this looks more normally distributed, right? The median rather is in the middle of this, closer to the middle of this box. It just looks more generally distributed correctly, and this looks more like a bell-shaped curve than our other situation did. Okay, mean was 57.27. Our standard error was 0.59, 0.059. Our 95% confidence interval was 57.13, 57.41, the same as we got before. So we know it's different than 57.6, except this time we're going to test our null hypothesis. And the way we're going to test our null hypothesis is we're going to use something that's called a t-test. Okay, this is kind of a preview on something that we're really going to get into next week.